This is for Year 10 Maths Pathways. We're just doing a recap on exercise 3.4 quadratic transformations. So let's start with a very basic case. If I have y equals x squared, we know the graph is a smiley face, so it looks something like this, okay? So in exercise 3.3, we would have plotted y equals x squared graphs, and that's the basic case. Now, so I'm going to call this the base case. Now, we're going to do some acrobatics with it. It's known as transformations. Okay, so we can do something called dilations. So if I have y equals ax squared, if a is greater than 1, then it becomes thinner. If a is between 0 and 1, so it's a fraction, it becomes fatter. Okay, if a is less than 1, then it's reflected, oh, less than 0, sorry, less than 0, it's reflected in the y-axis. Okay, and it obviously can still become fatter or thinner depending on how much it is less than 0. So, for example, if a is -2, then it becomes fatter, thinner, but also reflected in the y-axis. So let's do some examples. So if I've got y equals, let's say 2x squared, I know that compared to the original graph, so y equals x squared, y equals 2x squared will become thinner, okay, because the a value is greater than 1. So we'll go y equals x squared plus, y equals 2x squared here. Okay. If I have y equals a half x squared, because a half, the a value is between 0 and 1, okay, if it happens to fall in that range, then we know that graph will become fatter. So the graph of y equals half x squared will be like this. Half x squared will be like that. What if I had y equals negative a half x squared? Can you see we have a negative here? So if the a value is negative, it's going to be reflected, so it's going to be a frown. And because we have a half, it means it's going to get fatter and a frown. So fatter and a frown would look something like this. Negative half x squared. Okay, so that's basically what dilations are. Okay, dilations are making the graph fatter or thinner. And obviously, if it's negative, then you reflect it in the x-axis. Now, that's not the only thing we're going to cover here, because that's just one aspect. This is just dilations. We've also got something known as translations. So translations are up, down, left, right. Okay, so up, down, left, right. So if I have y equals x squared plus 1, what this does to the graph is that it moves the graph up 1. Okay, so we got 0, 1 there. If I have y equals x squared minus 4, then the whole graph shifts down 4. So your turning point would be 0, -4. Okay. Sometimes you don't need to, go through the algebra because it's so simple. You know what's happened to the original graph. Okay, it's either moved up 1, down 4, or something else. What if I had y equals? So I'll test you a bit. What if I had y equals negative x plus 1? Well, the negative, what does it do? Okay, it hasn't gone fatter or thinner because the number in front of the x squared is still 1. What the negative does is that it reflects it, and we're moving the graph up 1. Okay, so what's happening here? It's a frown, and we've gone up 1. So secant transformation is that this is the original graph. It's been frowned, so it looks like this. So this is y equals x squared, y equals negative x squared. And what's also happened now is that the frowned graph has been moved up 1. So it looks something like that. Your turning point is still at 0, -1. 0, 1, sorry. So it looks something like this, if I were to draw it. 0, 1, like that. Okay, does that make sense? Other transformations. So these are pretty much up, down. Okay, so these are pretty much up down. We'll do left right. So for left right transformations, you have to have the number inside a bracket with the x. Okay, what I mean by that is if I have x minus 4 squared, x minus 4 squared, then remember how I said that if it's in a bracket, it's opposite to what you expect. So opposite to what you expect. So what's happening here is that we're expecting it to go -4 to the left, and in fact it's going 4 to the right, positive 4 to the right. So what this does to the graph is that it moves it 4 to the right. Okay. So similarly, if I had x plus 3 squared, then what that does is that it moves it 3 to the left, because that's opposite to what you expect. Okay, so it looks something like that. And then you 3. So left-right transformations, you always look at what numbers in with the x, okay, inside a bracket for quadratics. Okay, we'll explore this further. Okay, so first of all, we will do like a combination of transformations. I would firstly like to introduce you to something called turning point form, but at a very basic sense, because we're gonna discuss this more in detail when we actually do the algebra on this. But this is just to get you to understand conceptually what we're doing when we're transforming. Okay, so if I were to see a graph in turning point form, so turning point form basically means like this. So if I see a graph that looks like that, this is known as turning point form. Okay, this whole thing is in turning point form. Why is it a turning point form? Because I can read directly what the turning point is from these letters. Okay, so the turning point from this equation, we know the graph has moved up C and uh, right B. Okay, so it's opposite to what you expect. So if it's moved right B and up C, the turning point will be at BC. So applying this, if I have y equals x plus 1 squared plus 4, can you see there's a difference between this x plus 4 and this, okay? This one moves the graph up 4, and this one moves the graph left 1, because it's opposite to what we expect. But if we combine the two, my turning point will be at, so we moved 1 to the left and up 4, so it'll be -1, 4. Okay, so if I were to draw the graph, I know that I'll move the graph -1 here, so it's here, and then you go up 4, so it's somewhere over here. So it'll be -1, 4, like this. So this is how we do graphs with multiple transformations. So let's do another one. If I have y equals -x plus 1 squared plus 4, what would that look like? Okay, the turning point's still -1, 4. Okay, remember opposite to what you expect here, and same as what you expect there. Okay, but we've got a complication of having a negative at the front, so it's a frown. Okay, so it's going to look, the graph would look something like this: -1, 4, but it's a frown, so it's going to look something like that. Okay, I'm not going to do the x's and y steps because we'll do that in another exercise, so I don't want to confuse you too much. But this is basically what this exercise is all about. It's just understanding the transformations. If I want to get really complicated, I could do something like this. Okay, so if I want this graph, I know it's a frown because we've got a negative at the front. We also have the complication of being fatter, and the turning point is still negative 1, 4. So if you were to graph it, it will look something like this. Negative 1, 4, but it'll be a bit fatter compared to that graph. Okay. Well, my graph might not be 100% accurate because I haven't figured out the x and y intercepts, but this is basically what I'm after. So this is the crux of transformations for graphs. So I'm hoping you get the basic idea of how they work. And if you know transformations, this will actually save you a lot of time on the test, because if you know the visual of what the graph looks like, then you don't need to find x-intercepts if there aren't any. Okay, you'll come across a lot of pain if you do, because you can't find any. Okay. Similarly, if there are x-intercepts, you got to make sure you find them. Right. Hopefully this helps. And also, very importantly, axis of symmetry is just the value of the x value of the turning point. So you go x equals negative 1 here, x equals negative 1, x equals negative 1. If I go back, axis of symmetry for this one here will be x equals negative 3, x equals 4, etc., etc. Okay. If the graph is in the middle, then go x equals 0 as the axis of symmetry. Okay. We're relying on the fact that coordinate graphs are symmetrical. Okay, so if you cut it in half, both halves would be mirrors of each other. So hopefully that helps you with the exercise.